Today we have a special super scientist guest. His name is Dr. Barrie Tan. He's been associate professor at the University of Massachusetts, holds a PhD in chemistry and biochemistry, but most notably he has a life's work of exploring and discovering some of the really important qualities of vitamin E and its actual components, because it is made up of quite different components, as we'll see, and they have great importance for human health. So we're going to delve in and explore his journey and also all of the technical information around vitamin D, or vitamin E, I should say, that's really important for our health over the long term. So great to meet you, Dr. Barrie Tan here.
Good morning. Good afternoon, and great to meet you. Just a small correction. I started my career as an assistant professor at the University of Massachusetts, and that's almost 30 years ago. So I've been doing this outside the university and delved into research for a long number of years.
Right, and I believe you have, of a company, and you invest a lot of your proceeds into more exploration, more research, and you have many patents around the technology we're going to talk about.
Yes, that is correct. I know we are different from the ocean apart in this interview here, and even further oceans apart. I got my PhD in New Zealand at the University of Otago. That's even further apart still. So right now we are a little bit closer to you. So I'm looking forward to this interview.
Well, actually, there's a coincidence, Barry. I was in New Zealand myself just a few weeks ago, visiting the world class manufacturing plant of a friend, Warren Matthews from Xtend-Life. And I'm helping him look with a devil's advocate view at various components for health. But I guess no matter where in the world we are, the science, the data, the evidence remains the same, I guess.
As far as human health is concerned, vitamin would work the same. So I'm looking forward to this.
Excellent, Barry. Well, we might start off actually with a 30,000 foot type view of vitamin E. And I was fascinated only a couple of months ago because I've done a lot of research in many aspects of health, but I had kind of not paid too much attention to vitamin E because of the news around the failed interventions where it didn't really help as much as was expected. But a few weeks ago, I got your white paper, your book, and I was just stunned at the sheer amount of data that indicates what supplements or what aspects of vitamin D are much more important for health, and all of the human randomized control trials that have been actually carried out on specific components. So we might start by going through vitamin E, which some people see as a bit boring, but get into the tocopherols and the tocotrienols, which are the two different components in it with very different properties that help decode why vitamin E has been maybe or not decoded properly for many decades.
Yes. This is a simplistic understanding. Vitamin E was discovered in the 1920s, almost 100 years ago, at University of California in Berkeley by two pediatricians. They are also anatomists. And then they found it, and that vitamin E, the first found one was alpha tocopherol, and they found that it's able to help the fetus and the development of the embryo. And for that reason alone, alpha tocopherol and the other vitamin E became a vitamin. Otherwise, had no chance to be, just for that. And then 40 years later, they gave to the VA hospital here rancid fat. We're not allowed to do experiment like that anymore. To patient in VA hospital, and then their body get oxidized, and then they found the lowest amount needed to prevent oxidation, and that would be about 12 IU at the time, and then they became a standard. But it's an erroneous movement because the VA hospital people on antioxidant health have no more reason and connection to the fact that the vitamin being an essential to health, and the essentiality came from the prevention of the fetus not able to carry to full term. In other words, it's lost in translation for what became a vitamin because the antioxidant and a number was given to it, to the original discovery and made it a vitamin, was essentially really for women because it's for the fetal growth. But that's the context. Then in the middle of these tocopherols, they discover all four. And then in the 50s and 60s, they discover additional vitamin E. At the time, until then, there was the four Greek letter alpha, beta, delta, gamma tocopherol. And then in the earlier literature, like in the 70s, if you Google and do PubMed, you find other Greek letters like nu, epsilon, and zeta tocopherol. Those are mislabeled. They're, they have they have corrected them, and they became also alpha, beta, delta, gamma tocotrienol. So now in big sweep, there are four tocopherols and four tocotrienols. Together, 8 of them that constitute the entire known family of vitamin E.
Perfect, right? So vitamin E, essentially, the mistakes that were made were to kind of mix tocotrienols in with the tocopherols, all as variants of one molecule, but they're quite different in properties and impacts on human health. And you then went on to research hugely the tocotrienols, and you discovered so much over the last couple of decades. So maybe we'll talk about those now, that the viewer understands the tocopherols, that they were focused on women and fetal health, and it's not really the big game. Let's talk a little around the tocotrienols and all of their mechanisms in many chronic diseases of modernity.
Okay. Again, I'm still staying at the 50,000 feet high, so that then we'll come down to the granular as we discuss more. Now, if you look at it chemically, which means the structure of the chemical, you can't change this. It is what it is, like the DNA that maps you and me, like that. We are 90 something percent same, but other than that, a small genetic difference make you more of a Caucasian and me more of an Asian. But otherwise, much of our things the same. So it's the same with vitamin E. They look very similar, but they are very distinguishable chemical feature. I think of a vitamin E molecule like a tadpole, like a sperm. It has a head and then a tail. So structurally, it looks like this. A tocopherol have a bigger head and a longer tail. And a tocotrienol have a much smaller head and a shorter tail. What is the significance of this? All vitamin E hangs around in the biomembrane, the cell wall of a cell, and all cells have cell wall. A tocopherol having a longer tail anchors deeply into the membrane. Less so for the tocotrienol. And then the head of a tocopherol is so big, it's water soluble. It sticks out closer to the water. And a tocotrienol has a smaller head, still in the water, but a little bit more recess into the lipid. So translated, when you have a free radical, and for the audience, we all need oxygen to live. We have to have oxygen. 1 in 1,000 or 1 in 10,000 oxygen that we need to exchange turn bad, turn raw. So when it turns raw, it usually tries to capture one of the fatty acid, which is the entire phospholipid, because it's the lowest lying fruit to oxidize something. And a tocopherol would move around slower into the cell because the tail is longer, anchors deeply to catch the oxygen radical. A tocotrienol shorter tail anchors less deeply, flies around 50 times faster than the tocopherol. They're still catching the bad guys, except that the tocotrienol can do it 50 times faster. That's it. So structurally, they are the same. They're uniquely situated into the cell membrane. The reason I took a little bit more time to capture this for the audience is this. Many of the audience, including me out there, we hear the word antioxidant one too many times. There's just too many. Everything is an antioxidant. To me, I want to delineate this. The antioxidant that I care about most is antioxidant that protects the lipid. Yes, our protein need to be protected. Our DNA need to be protected. Our whole body need to be protected from oxidative damage. But why do I say the lipid need the most protection? Because all the fat are in the cell wall, and the fat is the easiest thing to get oxidized. If you don't believe in me, you put a stick of butter in the summertime at about melting temperature. You smell it going rancid faster than most things you remember. A roadkill, for example, usually we think of the protein going bad. It is not. The bad smell of a roadkill is the oxidized fat. The first thing to go bad is the fat. And that those fat are mostly in the cell wall, and that's where the vitamin E resides. They need to protect the cell wall. So when I talk about antioxidant, I care most about protecting our fat from going bad first.
Right, excellent, Barry. And that resonates so much with me because I work mainly in cardiovascular disease research for Irish Heart Disease Awareness. But of course, the whole oxidization of low density lipoprotein, the whole discussion around polyunsaturated fats in the outer shell getting oxidized, radical oxygen species are such an enormous part of the damaging effects of modern inflammatory diseases. So what we're talking about here is tocotrienols' importance in some of the most fundamental processes of aging, really.
It is correct. Now, in another perspective, which is also setting the stage at the 30,000 feet high, I took time to get into this. In each human body, anywhere from about 60 on the low side to 80 on the relatively high side kilogram of a person, we have about 38 trillion cells. You can Google and find this out. That's a big number. It approximates to 5,000 times the population of the Earth. Now, so that's a very big number. So each person contains that many cells. And all of it has a cell wall. Just like a castle, it has a moat. And the moat has water. So outside facing the moat is a phosphate because they're water liking. And inside the moat is concrete. That would be the lipids, like that. So if you think about the cell wall, they're mostly lipids. Some people call it fat, some people call it fatty acid, like that. Almost 95% or greater will be fat. Then the second most abundant thing on the cell wall would be cholesterol to move the fluidity of the cell, like that. And then there'll be one or two large clumsy protein. They're usually to attract certain glucose from coming in, calcium from going in and out, like that. So that's why the protein are there. So short of all these major things I mentioned, fatty acid the most, cholesterol less, and then one or two protein, then left after that, it would be the antioxidant. And of all the thousands and thousands of antioxidants out there, vitamin E composed 90% or more of the antioxidant in the cell wall. This research was done by an Austrian professor in the 1980s. If you dig it out, it actually is so searching so that you can eliminate all these other wonderful antioxidants you and I know about, like astaxanthin, lutein, and CoQ10. They don't sit well in the phospholipid. It has to look like a tadpole, and those are vitamin E molecule. So things like EGCG, things like curcumin, things like quercetin, resveratrol, we all hear about this. They do not have a structure and shape of a tadpole. Vitamin E does. And so now, if I capture the audience attention, 90% of all the antioxidant cell wall are vitamin E. So now, in vitamin E, you have tocopherol and you have tocotrienol, much smaller like that, the head. In 1970, Professor Lester Packer in UC Berkeley, the same place that discovered vitamin E 70 years earlier, Dr. Packer was intrigued. He found that tocotrienol is able to capture the oxygen radical 50 times faster. So he considered that not believable because 50 times faster will be 5,000%. It's one thing to say that this is more active, 50%, 80%, but 5,000%. So he need to have a rationale. he discovered that because the tail of a tocotrienol is shorter, tocopherol tail is much longer, he is able to use a machine and able to see that the tocotrienol literally spin on the cell wall 50 times faster. And for that reason, it is more potent. So it is not due to stoichiometry, more is better. It's the same amount, but able to spin 50 times. So in the US, I don't know if you have the same term in the UK. In the US, we think of a policeman is staying in the confine of a town. Only a state trooper in the US is able to cross the entire state. So both of them catch the bad guys, just that the state trooper is able to cover a much larger circumscribed area, which means the whole cell much faster.
Right, Barry. And that's fascinating. And as we go through this conversation and we get later on to randomized control trials and everything else around tocotrienols, we may find it's more like the FBI. It's at an even higher level across the country.
That is right. Now, if it helps, I know it's a mouthful of a word. For tocopherol, you can just say T. And tocotrienol, because it got 3 double bond, most scientists, after they repeat the word several times, they acronize it to T3. So it's vitamin E with 3 double bond in the tail. And it's because of the 3 double bond, the tail got shorter. That's it. So a tocopherol have a saturated tail. The tail is longer. So when you have 3 double bonds in the middle, the tail gets shorter. So that's it. That's just a chemical description of the molecule.
Right. So tocotrienols, as with the structure you describe, and of course, structure is everything in molecules for their functionality. They've got this 50x rapid mobility or motility around the shell. And they can, I guess people need to understand that a lot of these chemical processes, you've got 38 trillion cells, and a lot of these processes are extremely rapid at the molecular level when you have oxidation. So you need a very rapid molecular mechanism to constantly counter the problem. And of course, as we eat and we metabolize, we're constantly producing free radicals. It's part of the process. There's a cost to eating and metabolizing, and we need all the systems to rapidly fix that exhaust system before it damages something else. So the tocotrienols, they are, and I know that vitamin E in general, as you said, 90% of the antioxidant machinery revolves around that. And I also knew that the HDL carries the vitamin E, and the whole lipoprotein transport system carries this crucial component around for the reasons we discussed. But the tocotrienols themselves then, besides the speed, in the physiology, they're much more active in doing many different jobs, affecting many different diseases potentially. So in your book, you have cardiovascular disease, you have metabolic syndrome, of course, type 2 diabetes, non-alcoholic fatty liver, cancers can be engaged in these mechanisms. So maybe we'll talk about tocotrienol with a varied set of modern chronic diseases and how it interacts. That'd be cool.
Yeah, all right. You introduce the concept that lipids travel in a body through particles, and we define this more descriptively like low density lipoprotein LDL, and then on the other hand, high density lipoprotein HDL. If you just make it sound like a down to earth thing, low density and high density. So the low density just means that it carries a lot more fat because fat floats in water. So they're low density. And the high density have less fat. So they're denser, so that they have high density. In other words, they have less fat, meaning they have more protein. Just think of protein sinks and then triglycerides floats in water. So low density lipoprotein will have more fat, and very low density lipoprotein, even more fat like that. And then high density like that. So it's a descriptive term on the size of the particle, and people get fancy and study the actual particle size. Now, in these kind of particle, We call them transport system. They deliver lipid material throughout the body, the 38 trillion cells we refer to. So think of them as buses. The depot of the bus is in the liver, because the liver recrunch them and make them different size buses, and then they go out like that. In the big picture perspective, every so often people change them, but in the big picture perspective, LDL transport cholesterol to the tissue, to the cells. In a good day, don't think pathology, just think physiology. In a good day, they deliver cholesterol and deliver lipid substances to all the cells. And then the HDL is the one that comes home back to the liver. So they are bringing things back to the liver. So when cholesterol is not used, they're brought back. So in the cholesterol perspective, we think of the LDL as bad cholesterol because they carry the cholesterol into the cell, which means that if you measure in blood, the LDL high, potentially you have high cholesterol like that. And the HDL brings it back. So if you have high HDL, that means that they are the one that bring the circulating cholesterol back to liver. I know you know, but the audience, I hope this is good to you, and that's how and that's how it works. So now I want to bring two concepts to the table on this existing discussion. One is regarding the transport of tocotrienol is seemingly different from tocopherol. It's a subtle nuance. And the second one is the state of this LDL bad cholesterol and the state of this HDL good cholesterol. So the first one, and the first one is on alpha tocopherol. There is a protein in the liver called alpha tocopherol transport protein. So when you have a transport protein, I call it a rite of passage. The protein grabs onto the molecule and desire it to go to the place that it needs. For example, all of us take vitamin A and beta carotene. It's naive to say that this vitamin A automatically go to the retina of the eye. They need to have a protein to take it to the eye. Or vitamin D, they go to the bone. They need to have a vitamin D transport protein and take it to the bone. Many critically needed vitamin have a transport protein. Well, vitamin E has one for alpha tocopherol, and alpha tocopherol only, none other. So this alpha tocopherol, this vitamin E transport protein ensure the alpha tocopherol is in the LDL particle so that it delivers to the various sites. This is used again and again by all the people that cling on to alpha tocopherol as the thing, and no other vitamin E is useful. I have a problem with that, but at least I tell you, I let you know what it is. For the tocotrienol, there is no transport protein, known. And for the other tocopherol, like gamma tocopherol, no transport protein known. So in the earliest of day when I got into this game, I was told, said, Dr. Tan, you're in a lost cause because your tocotrienol have no transport protein. Nature doesn't make it useful. I had a problem with that, and I was also troubled by that. So I decided to do animal study. When I did animal study, if it were to be true that without the transport protein, it is useless because it cannot transport to other things because we have this structured understanding of how the LDL particle did it. Then I have a problem with that because then it's what? Then it's pooped off. See, how else can I understand that? I'm also a decent human being with a common sense. I'm not just a scientist. I ask questions like this. But when I did animal study, Ivor, what I found was this tocotrienol is already deposited into the adipose tissue, already in the liver, already in the brain, and already in the lung. Well, then, when my colleague said that, then you know something? You have a mechanism. Your mechanism is not necessarily wrong. Your mechanism is incomplete, insufficient. And so you got to think through, but don't use the mechanism as an exclusive explanation for the absorption of vitamin E. So today I found out this. Today, it doesn't literally mean today. When we cannulate, we cut the animal thing and let the vitamin E go through with tocotrienol. We notice that the tocotrienol is got into the lymphatic system before it get to the circulating system. So in the lymphatic system, we have about 30,000 miles of arteries, and we have approximately twice the amount of lymphatic system. And the lymphatic system have no heart. You have to go to peristalsis. And in the lymphatic system, most of the tocotrienol, or much of them, has already been deposited into the organ.
And actually, Barry, yeah, that's a great thing to go through in detail, because I was so struck reading the white paper, which is really comprehensive, by the way. I'm going to attach it to this podcast. But to explain that mechanism, when I saw it, that the tocotrienol comes in lymphatic system, and it actually disappears relatively quickly in the blood, which looks like, hey, it's gone away. But it's because it's so preferentially absorbed into all these organ systems, which kind of tells you something evolutionarily. If all these organ systems are rapidly taking up tocotrienol, and the tocopherol, in a very different way, it gets brought back to the liver to be kind of managed and sent out as appropriate. So it's a very different thing, right?
Very different thing. And I would say that precisely because I know I'm jumping the gun a little bit, but precisely because of that, the normal current recommended daily allowance in Europe is a little lower than in the US, but not by much. It's about 9 to 12 in Europe. In the US, it's about 15 milligram. I believe this 10 to 15 milligram gotten from our diet is adequate for us for alpha tocopherol, because we have a system in place that we have the alpha tocopherol that recycles it. So with this, I believe one of the major problem in all the randomized trial with alpha tocopherol is this: they use 400 milligram or 600 milligram with so huge amount, it completely inundate our system because it recycle again and again. People are just talking that it go back into the liver, into the other places is no good. But the reason it goes back into the liver and other places is no good is because we have a conservatory called alpha tocopherol transport protein that tries to ensure that the alpha tocopherol is recycled. Now, that system's supposed to work if we do not supplement 20 to 40 times more tocopherol. There will never be a proper argument. However, for tocotrienol, it's different. It's very different. I have studied in the American diet. We only got a mere, almost woefully inadequate 2 or 3 milligram of tocotrienol. Then, and tocotrienol is not conserved like the way the tocopherol is. So when we got to animal study, it is just night and day between tocopherol. We compare it to the nth degree because people can ask me about alpha tocopherol. When we use alpha tocopherol, nada. Nothing happened like this, And then we use tocotrienol, it kills the cancer, it brings down the cardiovascular disease. And then we did this subtle nuance. We use tocotrienol, we add back tocopherol. And when we do, we systematically see tocopherol mute the function of tocotrienol. If I know that I'm jumping the gun, as you go on to ask me this is, usually I wouldn't be so passionate. I'm a scientist at heart. Yes, I have a company make this. I'm trying to deliver health to people. If it doesn't work, I eventually will not have a business. So for me, this is very thrilling. After so many years, I'm finally finding something. And people even today challenge me. Say, well, Dr. Tan, if plant make a mix of tocopherol, tocotrienol, and tocopherol, but then your tocotrienol must be synthetic or artificial. No, it's not. I discovered this from the plant annatto. The annatto plant uniquely have a tocopherol-free tocotrienol. It even get me, I don't know if you plan to ask me, why I think the annatto plant makes this unique tocotrienol free of tocopherol for its own sake. No plant make vitamin E for human being. We just have grandiose understanding. They make it for their own procreation and protection and survival.
Absolutely, Barry. And you know what? We're going to come to that for sure, as in the whole history of discovery, which is fascinating, and the annatto and the different plants that you can extract and purify from. But that discussion on tocopherol there versus tocotrienol, that's worth dwelling on for a moment. So historically, tocopherol, you're probably getting in the last few decades around 15 milligrams in the diet, and that's plenty, because we've got a conservation mechanisms to kind of keep it at a reasonable level. But I guess in the last few decades, tocotrienol, we're getting very little relatively, and it's taken in and used immediately and absorbed into the system. So all of the work that was done, and we might get into this now, in all those RCTs, control trials with tocopherol, they always pretty much use tocopherol. I mean, overwhelmingly. And the interesting thing is, not only did they use tocopherol, which if someone 15 milligrams is enough, and they kind of used like 200 or 400, which is kind of OD, but also when they did of tocotrienol, by having tocopherol in there, I think above 15% in the mix from your white paper, it actually negates or stops the absorption or function of the tocotrienol. So the whole research of trying to improve human health with vitamin E derivatives in the past few decades has all been kind of misguided, really.
Yes, I would agree with that. You touch on 2 points. Hopefully, I can answer them in this manner. On the first part, why, how did it come about that we use alpha tocopherol on this randomized trial for this huge trial? There are just about no clinical trials as large as the vitamin E trial. Had it worked, it will be a colossal benefit to the whole universe, because no other trials, even the pharmaceutical company don't fund trials this size, because they're like 30,000 and they're done by esteemed university like Harvard University, like that. So, and the second part you said about the interference, the tocopherol to the tocotrienol. So I answer the first part. The advent of tocopherol using in the popular place is like after it came about that vitamin E is alpha tocopherol for the fetal resorption and can protect oxidative health. And during this time, the theory of antioxidation and protection in the body, it got higher and higher and higher. And vitamin E, as in alpha tocopherol, because alpha tocopherol is the only known thing then, tocotrienol was discovered 50 years after. So the status of alpha tocopherol get higher and higher as an antioxidant, and then the theory get better. So it came to 1970, late 70. So people were designing clinical trials, and 1980s, the trial started. Initially, they used synthetic vitamin E, which is DL alpha tocopherol, and then in the earlier study, and then when the study was equivocal, then they changed to natural alpha tocopherol, but still always alpha tocopherol. And the amount used is as low as 400 milligram and as high as 600 milligram in that dose level. So initially, they found out that, I'm just giving you a very fast review. Initially, they found out that their problem, the prostate cancer, rather than, first, nothing happened. And then later, maybe prostate cancer, maybe breast cancer, and maybe lung cancer. So this sent out the alarm bell. And then more recently, in the last 10 years, maybe even problem with cardiovascular health. Then, oh my goodness, they give alpha tocopherol to prevent cancer, to support cardiovascular health, and now possibly can even cause cancer and possibly can make cardiovascular health. So this is with alpha tocopherol with doses 400 to 600 milligrams. So that's the alpha tocopherol story. And then there even is a political incline, because many of them were done but in men. So in the last study on the cardiovascular health, they said in Women Health Initiative, part political, partly because they should champion the health of women, because most of the study were done on men. So the postmenopausal women, 5,000 strong. They gave women, postmenopausal women, 600. This is really bad news. They saw that they have increased risk in cardiovascular outcome in women when they were looking for the opposite. So right now it's kind of like putting vinegar over a wound. It's bad enough to have a wound, vinegar over a wound. So that's the vitamin E story as in alpha tocopherol. I simply don't think that the alpha tocopherol have no use in our body. The use in our body is good, up to 10 to 15 milligram, which we can get from our diet. That's it. Beyond that is a lost cause, I believe.
And you know what, Barry? Then the whole supplement industry pushing the generic kind of mistaken concept of tocopherol, the generic vitamin E, the classic one. That's all probably largely worthless, especially in people getting 15 milligram from their food, which is better, and possibly harmful as demonstrated. So it's a case where a misunderstanding doesn't just miss an insight, but it actually destroys an insight or damages a potential breakthrough. It reminds me actually of one with vitamin D. Now, there is controversy around vitamin D supplementation and whether or not it really matches getting the sun's UV, which creates other photo products and may account for high vitamin D correlating to better health. But I remember one trial where they took elderly people and they wanted to look at fractures and all that kind of thing. And they gave them, even though the dose for vitamin D is 4,000 a day max, and it used to be 600 microunits, they actually gave these elderly people twice a year 100,000 units in a single intravenous. And I know I can see the shock in your face, but I could not believe they did that, because these are people who are supposedly knowledgeable enough to do an intervention. They do something like that, and the dose defines the poison, and anything that's beneficial by its nature, if you give a lot of it, it'll damage you because it has to be active. So it really resonates, this story, with me, and it just makes sense that vitamin E in general is really important in the body. Why would giving more backfire? And I guess this is the explanation. In contrast, though, then the tocotrienols, the evidence for them when you actually give more or supplement is dramatically different, right?
Yes, that is right. Just to touch on the vitamin D, and then I go back to why huge amount in vitamin E, as in alpha tocopherol, is damaging. I think that the good level of vitamin D, because it helped to make strong bone, is about 2,000 IU, and not the huge amount, 100,000 that people give, and given intravenously like that. But there are supplement out there on vitamin D. They are 5,000, even 10,000. I believe that they are too high. About 2,000, more than 1,000 to 2,000 is about the preponderance of published study that I saw like that. Now, and also the vitamin D thing has vitamin K connected to it, and it also has some calcium, other, so it's not so black and white. Now on the vitamin E thing, there are many constructs. One of them is closer to your neck of wood than mine. It was published in the Queen's University Belfast in 2012. And I was surprised. I picked it up in one of my huge number of papers that I read and forgot about it, and then brought it back. When you talk about the lipoprotein particles earlier, you have LDL particles, and then you have HDL particle, the HDL being the good, the LDL being the bad, like that. At least we demonize them and set it up like that. Typically, the understanding is LDL particle is potentially not good because they ship out a lot of cholesterol. However, pathologists understand that until the LDL particle is oxidized, it is not atherogenic. So if it's oxidized LDL particle, then it becomes atherogenic. Usually people don't study such in the HDL particle. So first, high alpha tocopherol oxidized LDL particle. Professor Roland Stocker from in Australia published this, and it's been quiet for a long time, in the 1970s. If you Google his name, Roland Stocker, in Sydney, Australia, he did this work in the 1990s, long time ago. Only with the small amount of vitamin C, then you can prevent the alpha tocopherol from oxidizing the LDL. See, so in other words, a double-edged sword. Then you fast forward 30 years in Queen's University. This lady at Queen's University studied HDL, and she noticed that if you give even as low as about I've forgotten the amount. I wish I remember it. A low amount, like 100 milligram, which is 3 times lower than what people study, that it would oxidize the HDL. So now there's enough particle construct with the HDL and LDL, both important to our life, that they could be oxidized by alpha tocopherol. They have not seen this with tocotrienol, not been able to duplicate. In fact, the delta tocotrienol have been shown in 2000 in the Texas clinical trial to prevent the oxidation of the LDL particle like that. So, but usually in our clinical trial, we study how the tocotrienol modulate, reduce the LDL and increase the HDL. We just study the particle size, but not the oxidative process. So there you have it. One explanation of using huge amount of alpha tocopherol is actually oxidizing this lipoprotein. Whether it's LDL or HDL, it's no good when you oxidize them. You essentially make this lipoprotein dysfunctional, which is not a good thing.
Absolutely not. And yeah, the oxidation of that outer phospholipid shell and fats in the particles is a huge deal. So, as you say, it's been essentially demonstrated. It's not just a theoretical, mechanistic thing. It's been demonstrated that the excess tocopherol actually does this. And that ties in logically then with the poor results that they got, because whatever about LDL oxidation and HDL oxidation, but if that's the case, you can expect that many other cellular processes may be negatively affected by the same excess of tocopherol. And like that's what all the trials were based on, not just 100, which demonstrates oxidation of lipoproteins, but as you say, 300, 400, 600 milligrams. So this is really fascinating stuff. And the tocotrienols then, generally speaking, the opposite result, certainly no deleterious effects. But I see across all of the randomized control trials in humans, not just in vitro, this signal of lowering of LDL, which will lower particle count and will tend towards always being beneficial, tending towards increasing HDL, lowering triglyceride, but also impacting inflammatory markers, multiple ones. So there's quite a lot of these. We won't go through them all here, but maybe we'll touch on now some of the randomized control trials and just give a slightly broader flavor of the general results coming out from multiple trials.
This is, you're referring to the tocotrienol or tocopherol?
Oh, sorry, tocotrienol. So to shift away from, I think we've established the myriad problems with tocopherol. So now maybe switching over and looking at the evidence base for adding tocotrienol to the diet or supplement or in whatever manner, and the actual randomized trial results and generally what they've shown across a range of markers.
Okay, all right. For the tocotrienol thing, it has a historical context. It was first done on the cardiovascular area, and then it was done on the cancer thing to follow. And then later on, it went to other chronic conditions. So first cardiovascular, then cancer, and then other kinds of chronic condition. How did the cardiovascular thing came about? And there's a story, and this story most people don't know. It is in the book also. I believe I wrote in the book. It was in the late 70s. There was a professor at University of Wisconsin, Asaf Qureshi. And there was also a USDA lab connected to University of Wisconsin in the middle of the US. He extracted oil from barley, and barley have very little oil and fat, but he did. And then this little tiny bits of oil, he gave it to a pig, and the pig was able to lower cholesterol. That was the first thing that they did. So they find the needle in the haystack and found out that it was a tocotrienol. So then they're able to figure out that was the first time they found a tocotrienol connected to the reduction of cholesterol. So that set the pace. At the time, he had a student, and the student later became a vice president of research in Bristol Myers Squibb, which is a large pharmaceutical company. So now you bring it to the 1980s, and this is just prior to the advent of statin drugs like that. So when they found that this could lower cholesterol, they found out the mechanism, how this could lower the cholesterol. So then they study it and first in animal, then in human being. Essentially, tocotrienol reduced cholesterol about 20%. Increase HDL not dramatically, about 3 to 5%. But that's, nothing bad about it, but increase 3 to 5%. Statin drugs usually does not increase HDL. And then much later, they found out that it also reduced triglyceride, which is what we take fish oil to reduce triglyceride, which is good for people with diabetes like that. So with that, clinical trials started. So when clinical trials started, they saw the decrease of this cholesterol, the LDL, and a slight increase of HDL. All good news. This is at the time when we got tocotrienol from palm oil. Then we saw that about 2 out of 5 studies did not lower cholesterol. 3 out of 5 studies did. So it's kind of approaching equivocal. So my colleague, Dr. Karashi, and I didn't like that. So it would be better if it 75% to 90% reduce cholesterol and 10-20% not, because of different phenotype of people, but not 40-60 or 45-55. It's too close to call about half-half. So when we look at the study, on the ones that didn't work, they tend to have higher amount of tocopherol. For the ones that did work, they tend to have lower amount of tocopherol. We weren't suspicious other than, hey, we got to think about this better. Why did we come to that conclusion then? Because we considered that the presence of alpha tocopherol should be innocuous. That means it should do nothing. It just sits there, But then it somehow coincides, and we weren't sure. So we decided that we're not going to do any more clinical trials. It's too expensive, too much time, like that. So we stopped. And Dr. Karashi went back to the lab. Nobody else would. He did it. He published it in Journal of Nutrition in 1997. He added this amount of tocotrienol, and then the cholesterol dropped. And he add more and drop more. They already shown that before. Then in another study, at the same amount of tocotrienol, he add a little bit of tocopherol. And then in another study, same amount of tocotrienol, more tocopherol. And eventually, same amount of tocotrienol, even more. And when he does that, remember, the tocotrienol exactly the same. The tocotrienol exactly the same. Tocopherol increase. When he did that, he saw that the cholesterol drop. This is a cholesterol drop systematically reduced in the drop. Eventually, the tocopherol is so high, it makes the tocotrienol unable to lower cholesterol. So we know, then he published a paper that tocopherol interferes with the function of tocotrienol. At the time, he said that anything more than 25% of tocopherol to the tocotrienol is no good. Later on clinical trial, it would be 15%. And of course, on all the study, because clinical trials take so long and so much money, we completely have the patient not take tocopherol at all. After we have established many, many animal study that it is no good. It will interfere. It blocks it does this way. It did different study. It blocks the effects of tamoxifen in women with breast cancer. It erases the effect of tocotrienol in colon cancer. It counteracts angiogenesis brought about by tocotrienol, and it simply blocks the absorption of tocopherol, so that because tocopherol have a rite of passage, it just goes straight in because the tocopherol transport protein, and so the other tocotrienol and other tocopherol is just blocked. And by the way, it not only, sometimes I say this, people say that I'm too evangelistic because I'm pushing tocotrienol, but in the 1980s, scientists already know if you use alpha tocopherol, it would block the absorption of gamma tocopherol. So I even told many companies that put the mixed tocopherol together, your gamma tocopherol is a lost cause because your alpha tocopherol would block the gamma tocopherol.
Yeah, and actually, you've been very clear there on that the tocopherol compounds, which they've been largely using mostly for decades in supplements, they block the action of tocotrienol, specifically in the LDL reduction, where I think it's working through the HMG-CoA pathway. But by inference, you would assume it's blocking many of the pathways of tocotrienol beneficial action. So that's a very clear point, and that's what confused the sphere for a long time. But you've just mentioned also that the alpha tocopherol, which is not nearly as useful as the delta tocopherol, the alpha also blocks the delta. So the tocopherol also blocks its own more useful kind of type. So it kind of really is a problem. Alpha tocopherol has dominated all the supplements, I believe, and it's the one with all of the questions you've raised around, yeah?
Yes, I think that with this alpha tocopherol, to the extent that you could, because you have many listeners on this, I think that the alpha tocopherol industry, which is 90% of the supplement out there, I think is well overrated and possibly do harm at this point. So that's my guess. And let me do one more explanation on alpha tocopherol, and then for the remaining time, if we can go back to tocotrienol, I'll be. You can see my passion in this is I'm really trying to learn on this, and so even I'm risking not talking about tocotrienol, which is my love, but the alpha tocopherol is really a problem. But let me tell you one last thing on this, on the alpha tocopherol, on two things. Alpha tocopherol affects the genotypes, meaning, and alpha tocopherol affects the detoxification program. Let me tell you on these two things. When we take alpha tocopherol, it affects the inflammation processes. This is published in 2012, very recent. What does that mean? Inflammation response are inflammation responses in our body to oxidative stress. Some of these inflammation responses are tumor necrosis factor. People can Google and find out, or interleukin. These are signals in our body that create responses when we are stressed by the outside. So when they take alpha tocopherol, they found that these responses are elevated rather than decreased. That is a problem. Now, then, and people did a test on this. There are people taking 50 milligram a day, and another group taking 400 milligram a day for 6 weeks, not a long time. And it is inconsequential to the low amount 50 milligram taking per day or the 400 milligram per day. They all change, increase the inflammatory responses. In all our clinical trials on tocotrienol, it decreased the inflammatory responses. You can Google and look at all the study. It is like that, one. And so that's a real problem and only published in 2012. The second one, this is published from Harvard University. Two, one, they theorize something and then they follow by a clinical trial. We in our liver have detoxification. If you take too much lipid material like vitamin D, vitamin K, omega-3 fish oil. They break it up and then they excrete them. If you take a pain medicine like acetaminophen, we call it Tylenol in this country, or aspirin, or any medication, you use certain amount you need. Whatever you don't need, it goes to the liver chops it up, and then you pee it off or poop it off. That's usually how it happens. So this kind of pathway is called detoxification pathway. The Harvard University group found out that when you take alpha tocopherol messed up this detoxification program, and therefore it is a problem. And then they already found out this problem with alpha tocopherol with cancer. So the most recent thing, they say that this can circumvent cardiovascular outcome if it blocks this. And then the theory was shown in 2014. They published again in 2018 and again in 2019. And then finally, there is a published paper on this alpha tocopherol in clinical trial. I'll just read to you. Usually I don't take it up to my face to read it to you. In this new study, they are now substantiated in the Women Health Initiative that alpha tocopherol elevate the risk of clinical vascular outcome in Women Health Initiative trial. And this was published only a few months ago. So I'm thinking that the risk of taking alpha tocopherol as a supplement is that you tiptoe around landmine. Why even bother? Just take it enough from a food is good. So I've done enough to put the nail in the coffin to my belief on alpha tocopherol. So right now, I'm going to answer all the good things about tocotrienol. I'm good with alpha tocopherol from my diet. So initially on the tocotrienol thing, it was done on cardiovascular health. So of late, because cardiovascular health cross over diabetes, metabolic syndrome, and fatty liver disease. So after we know that it lowered the lipid profile, including triglyceride, we're very happy with lowering triglyceride. Why? Because people who are diabetic and pre-diabetic, people with metabolic syndrome, they have high triglyceride. You take 2, 3, 4 grams of fish oil to lower the triglyceride, a good thing. And by the way, in fish oil, they put alpha tocopherol as an antioxidant. So if you take 2, 3 grams of fish oil, you probably already have another 2, 3, 4 milligrams of alpha tocopherol. So I really don't need more alpha tocopherol. But you will lower the triglyceride, a good thing. But a subtext, if you take too much omega-3, it can potentially increase the LDL. People know about that. But tocotrienol decrease the LDL. So it is a wonderful thing to take fish oil to lower triglyceride with tocotrienol, which would also lower triglyceride. And at the same time, the tocotrienol will prevent the LDL from going up by the fish oil. So keep that in mind. So that is a good combo. If there were to be a good combo, that would be a good one for diabetes.
Yeah, for sure, and that's a great synergy. And as you mentioned, I mean, there's multiple randomized human control trials indicating all of these signals that we're talking about. But yeah, by having LDL lower, HDL higher, triglyceride lower, your triglyceride over HDL ratio is improving, your total cholesterol over HDL, which is what they use in all the risk algorithms, is improving. And basically every marker from the lipid system is improving in all the right directions, even with synergies. So that's great news. I love anything that'll lower TNF alpha and IL-1 beta and these. And I think there's quite a bit of a randomized trial too showing, quite significant reduction in the all-important inflammatory markers. So maybe touch on a couple of those, a little more depth.
Okay, on the Dr. Qureshi published some work on this inflammatory marker like tumor necrosis factor, NF-kappa B, interleukin 6. This inflammation, they are further upstream, And further downstream, all the way to clinical trials, we simply also take a read on the C-reactive protein. And typically, and not surprising to me, when we take the C-reactive protein, they drop about 30-40%. Very nice drop. They're further downstream. And then in animal study, when we look at the interleukin and NF-kappa B, we have published so many papers on it. They typically would drop about 20-30% in many animal study, in the liver, in the lung, in the cell line, many study. And in the human study, we would draw blood and then we fractionate it out and study them. They also typically drop in those ranges that I mentioned to you, like that. And even in the most recent one, I'm digressing now, and actually I'll wait for the digress, but if I forget, ask me about inflammatory marker on people with hepatitis C. But that was an accidental find on that one, on inflammatory marker. So with all of this cardiovascular concern, Ivor, we decided that, okay, we have to choose something to study on. So we decided that enough had been done and studied on metabolic syndrome and diabetes. We decided that there is a case based on animal study that because of the lowering of the triglyceride and all these wonderful things, how about we focus on NAFLD, meaning non-alcohol fatty liver disease? It's a clumsy term. Mayo Clinic discovered it in the 1980s that people, NAFLD is called like that. Their liver look like somebody have cirrhosis because of alcohol drinking damages, like that. They look the same. So who would have guessed? You fast forward to 2020, 80 million Americans have fatty liver disease, similar to people who drinking excessive amount of alcohol. Who would have guessed that? So right now, rather than when we're drinking ourselves to death, we're actually eating huge amount of fat to death. So we decided that we go after this one. And there are no drugs now to treat NAFLD. It was called NAFLD because the Mayo Clinic doctor treated a patient and asked the patient, your fatty is liver, are you drinking a lot of alcohol? To which the patient said, no, I'm not an alcohol drinker. To which the doctor is accusing that he's not telling the truth, to which it irritates the patient to say that I am not an alcohol drinker. That was when the doctor wrote a piece in the Mayo Clinic to say non-alcohol related fatty liver disease. And that term has stuck to this day, you know? So now we...
Oh, and indeed on that, a lot of people have reported to me that they still get pressure from their doctors because their GGT or gamma glutamyl transferase is high and they have other liver problems, but they're driven by excessive sugars and carbohydrates. I mean, they don't even drink any alcohol, but they still get the pressure. But sorry, go ahead, Barry. Yeah.
Thank you for interject me at any time. So we are very thrilled about this NAFLD study. First, we were not sure. So we started with a 3-month study. I actually was asking the professor to do a 3-month study and then go on further like a time dependent and do a 6 months after that. But he actually did a 3-month study and he stopped it. So I was a little bit ticked off, but anyway, he stopped it. So the patient is gone fine. So he reported the studies published. So I give you the shorthand version. The triglyceride dropped about 15%, not bad. The C-reactive protein dropped about 20%, good. And then the liver enzyme dropped about 20%, very good. And then the GGT, as you mentioned, also dropped about, then I said, I'm liking this. And then they have an ultrasound to do the fatty liver index because the ultrasound can pick up the extent of fat, also dropped about 15%. Then I say, it's good. So he felt bad and then he continued to say, so now he finished a 6-month study. Remember, this is not 3 months and then follow up 3 months. This is an independent, brand new study that is 6 months, which is now I'm looking back. Oh, thank you very much for doing. So he did that. And the study will be published in the next 3 to 4 months. So I'll give you a sneak preview. it further dropped by another 30-40% of the numbers I gave to you. So that means the liver enzyme dropped to 20 something percent, the C-reactive protein 28%, and what the GGT also dropped. Interestingly enough, these are overweight people, clearly have NAFLD. The BMI is about 28 to 30, so they're overweight. In the 3-month study, they drop about 10 pounds. And in the 6-month study, they drop about 18 pounds. There's nothing to sneeze at. We were not actually looking for them to lower weight, and we are not studying a weight loss product. But they are any people with NAFLD or diabetic, losing weight is a good sign. So they lost 10 pounds 3 months, 18 pounds in 6 months. I'm liking this. So I discussed with my partner. I want to really make this thing tank type. I'm committed to this, Ivor. I said, can we do a 12-month study? So we started the 12-month study. The 6-month study will be published soon. So we got to be ahead of the time. So we do a study, 12-month study. This time it will be they're all gold standard in the sense that they're double-blind placebo-controlled trials. In the 12-month study, we're doing it much further, independent. The 3-month, the 6-month, and the 12-month study are totally independent study. They're not from the same subject. In the 12-month study that we gave to the patient, this time we are going to use CAT scan or nuclear magnetic resonance to study the fat in the spleen as well as in the liver. So with it, we will pin this thing down. So this is as good as it's ever going to get. If it is, I trust I would be able to ask regulatory bodies for this sort of NAFLD, which cross over to cardiovascular health, to see how this get damage to the liver can be mitigated. It is very important because the liver does 600 to 700 function. You cannot give the person an artificial liver. It's not possible. You may have an artificial kidney, artificial pancreas maybe, an artificial heart, but you cannot give artificial liver because it does 600 to 700 function. So if people are on a transplant list, that's not good. So before that, I'm hoping to capture this. If it is, this would be a fantastic day for tocotrienol.
Yeah, for sure. I mean, they're impressive reductions, and again, for a single intervention and the all-important double-blind, placebo-controlled, which you really do need to really kind of batten things down with any intervention. It makes the data all the more powerful when you can actually depend on percentages of shift and change. Well, you know what? We've talked quite a bit about the RCTs, and it's very exciting stuff. And we'll have a link to your book with a code, which of course has all the references in it and everything we're talking about. But the story then of your discovery, we might cover that now that people have heard a lot about the actual compounds and understand it. The story of discovery in your case, and the extraction from the different plant materials and the different kind of optimization. Certain plant materials have much more of delta, tocotrienol, and that's very much the one that has the most powerful properties in vitro or in trials. So maybe that story of discovery compressed.
Thank you. I started my career in 1982 at the University of Massachusetts, and I discovered tocotrienol from palm first, and it's about 25% tocopherol, 75% tocotrienol. And palm oil is just fat, so you remove all the 99% fat, and then palm oil is yellow color. I was going to go after the carotene, so I removed the carotene and then put it here to study. And then there's always something like 0.1%, a yellowish, dark yellowish oil. I don't know what it was. So I analyzed it, got high antioxidant potential. That was my entrance into vitamin E study, 1982-83. That was the year. But I was intrigued that there are 4 peaks. Only one of them is alpha tocopherol. The three of them, I study them, and they're tocotrienol, 25% of tocopherol, 75% of tocotrienol. That got me in. And then fast forward another 5 years, I discovered this from rice also. So rice bran oil also have tocotrienol like that. So I was happy momentarily. But then when I look at it, it also contained 4 peaks, 1 alpha tocopherol and 3 tocotrienol, except that the alpha tocopherol is 50%, much higher. And the tocotrienol is 50% together. So I didn't like that so much because I'm looking for higher tocotrienol, more content of tocotrienol. Nevertheless, palm and rice tocotrienol was my discovery. My name is attached to that if you see published paper like that. So by the time I did the rice tocotrienol, the annatto is not in the picture. Remember, my first love is the color of life, the carotenoids, because palm oil, palm carotene, you see the color. And then rice, if you look at it, has a little bit of color, but mostly rice was my unusual detour because I went to the Prince of Thailand and then I did study with them. Rice is sacred to the Thai people. I did that, you know. So the first two, palm from Malaysia and rice from Thailand, is my Eastern, because probably from my Asian background. So now after that, I was a little bit disappointed, possibly a little bit disillusioned. Remember, I came back to US. I live in Massachusetts, far away from Asia, other than my Asian descent. So I decided to go back to my first love. My first love was carotenoid. And that was about 1994. Professor Johanna Seedon, a Harvard University ophthalmologist, she discovered that on the back flanking of the eye, the retina, a blue filter, and the blue filter are carotenoid called lutein and zeaxanthin. Everybody now know zeaxanthin and lutein is good for macular degeneration, blah, 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 understand. But in 1994, people don't know much about this. So she did this. Aha, that's interesting. I happen to know that in South America, the giant marigold, the normal marigold is this, about 4 or 5 times bigger is this giant marigold found in Peru, like that. If you eat Chinese food like a bao, the big giant bao, you go to Chinatown, like that size, you know. So I went to South America. Sure enough, I found this giant marigold with the petal, with lots of lutein. So I got what I went there for. Remember, I was disappointed with my tocotrienol study, went back to my first love, saw this and went to South America. Then literally 30 feet away from me, from where I saw this giant marigold, I found the annatto plant. It did not wow me initially. It wowed me because the fruit, can you help me? Can you bring that picture here? It wowed me because the fruit is very attractive. The other one is better. Sorry, I'm asking my colleague to bring a picture.
Oh,
I will block my face, and you can see the picture. And it's, as I'll cover it, and
whoa. I've seen in your book, but it's a beautiful plant, isn't it?
That is a beautiful plant. If you look at this picture here, this is a pod, and the pod is a fruit, and this is a seed. If you think of a fruit usually have a flesh. This is an exceedingly unusual fruit. Where the flesh is air. It just got the seed,
wow,
and then the cover of the fruit. No other plant are like that. This plant make the seed look like a fruit, smell floral, and deceive the birds of the air and the Amazonian tree frog, so that they thought that this would be a fruit. They swallow the seed and procreate the seed by pooping off elsewhere. That's it.
Right.
So this color here this intense a red color is a carotene. The carotene again.
Right.
So I surmise that there must be something very powerful antioxidant that protect the carotene from going bad. Little did I know that it would be a tocotrienol. I expected it to be a polyphenol like resveratrol, quercetin, like that, but I did not find that. I found that this plant make the most potent vitamin E on earth. Free, not tocopherol, is inferior. Instead, it makes tocotrienol, and the most potent one, 90% delta tocotrienol and 10% gamma tocotrienol. I immediately told my colleague, the aging Dr. Asaf Qureshi, the person that first discovered tocotrienol function. And I remember the first comment he told me, if tocotrienol works to mitigate human maladies, this tocotrienol from annatto better work. If it doesn't, all costs for tocotrienol will be lost. That was 22 years ago. My last 22 years, my entire life was arrested and returned back to tocotrienol. What I went to South America to look for keratin. So that's amazing. So sorry about that. A little very dramatic story.
Well, no, it's a fantastic story and such an amazing, it's so fortuitous or serendipity to go there and to actually trip back over your first love and find what's almost certainly the most concentrated perfect form of these tocotrienols. And then you develop the extraction processes. I think you have patents around the PAM and the annatto to extract these in a safe manner without damaging the molecules. A brief word on that?
Oh, yes. That detour took me 10 years. My training is in chemistry, and I'm not by training an engineer, but I decided that I need to know, is one thing to discover this compound, and it's another thing to know that this compound is so good. If I cannot get this compound out, essentially, I'm not able to reduce this to practice. If I cannot reduce it to practice, people cannot have it. So for 10 years, I've been involved in working with this. And my wonderful wife said that you have discovered something so great. Can you possibly not use very toxic chemical or very caustic chemical or horrible industrial solvent to pull it out? It's very easy to use all these kind of chemical and solvent to do it. So she's giving me a huge challenge. So the 10 years, what I have done with it was that I use a physical technique free of solvent, free of chemical or any some such thing, only use food grade material to extract it. So basically I use an evaporative distilling thing to distill the vitamin E tocotrienol to the highest concentration possible. So right now it is approved by the FDA, a generally recognized as safe grass, and we are going to regulatory process in EU. It's approved in Australia, and it's also approved in Canada. So Health Canada have approved it. I'm exceedingly happy about this. So dovetail with the NAFLD study I mentioned, should that be successful, the Canadian government will apply the Canadian government for approval for use in people with NAFLD. I just thought that before I go away, I mentioned that the plant makes the annatto to deceive the birds of the air and the tree frog. I was in Tampa, Florida many years ago. I happened to see a tree frog right in the middle. Remember, the whole pot is about the size of a fig, a little bit bigger than a grape. Amazonian tree frog is about the size of an American penny or a dime, very small. So I'll show you an enlarged picture of tree frog. I'm really proud. This is my second proud thing that I see. So that frog, that seed is about the size of a grape seed. That frog is only about, the diameter of the frog is no more than 1 centimeter. So that's an example that is taking a shade, a shelter in the pot. But otherwise, they'll swallow the seed, thinking it is the fruit. So this is, I'm very proud of this picture. Just wanted to show you. So no science there, just my amateur photography.
Excellent. Hell of a photo. And you know what? We covered a lot of science here already, so that's a nice break. And you know, I know you have a hard stop as well, and I want to respect that, Barry. But you did mention to come back to Hep C and hepatitis C specifically and benefits those people could get. I,
Yes. Thank you. I actually had forgotten about that. Yeah. You know, when the doctor was randomizing the study, that's a beautiful story also. Please tell other people about this story. So not everything in life is purely based on science, although I'm really grateful to be guided by science. So when we were randomizing the patients for fatty liver disease, so when they screen them, they have to take blood work. So if they have malignancy, if they have diabetes, they are excluded. So it is if they have hepatitis C. So when they did the test, those that malignancy, diabetes, and hepatitis C will be excluded. I know that they excluded these people. I did not know after they exclude them, a bigger number of people with NAFLD have Hep C. So they gave this, they make the study happen. What they didn't tell me was they decided to give the patient who had hepatitis C Tocotrienols. It's not the study. It was just an aside. Are you with me? They gave them
yes.
500 milligram, and there were about 12 of them. So it's a pilot study. So, and after 2 months, 500 milligram hepatitis C patient for about 2 months, and they saw that the tumor necrosis factor, NF-kappa B, and the viral load, check this out, the viral load of the Hep C dropped in the patient. So now the severity of the virus increased. I had no idea what the mechanism is. I don't know everything in life, including vitamin E. I do not know what the mechanism on how it went after the virus, but it is good news enough for me that the viral load of this hepatitis C patient dropped. That's it. It was purely as an aside. Would you believe this? We set it out to study NAFLD, and then they decided to. Now, whether we will pursue this and do a proper clinical trial on Hep C, we don't know. But because you mentioned that you are a very gung-ho and want to know about tumor necrosis factor and all this, it does lower the inflammatory responses of this Hep C patient.
Very good, and that's a great story. I mean, that's just extra evidence that was got just because someone was, you know, innovative enough or took the initiative to go and try something out, which is fine. It is a pilot study. But I know the NF-kappa B. I recently interviewed Dr. Dale Bredesen, the expert on Alzheimer's. Probably one of the world's foremost authorities, and he spoke, of course, of the importance of NF-kappa B pathways in Alzheimer's and many other chronic diseases. And TNF alpha is basically ubiquitous in modern chronic disease as a marker. So all of these things are really fascinating. I'm going to really enjoy watching more data emerge in the coming years, and indeed your 12-month trial. And, you know, we might get back together again to do a real hardcore biochem and chemistry discussion. I know we tried to keep this one at my request to be applicable to a broad audience, but I'm just thinking we might get into the weeds in a future discussion.
Wow. Well, thank you. I look forward to that. I don't know, in the some closing remarks that I have, we are going after dementia because you mentioned about Alzheimer's disease. We're studying dementia and COPD and asthma. Currently, these two are only in animal study. I need to have strong enough, firm enough data. It's indicative before we see if we would do a clinical trial. We currently have several clinical trial. One, the NAFLD, the other one is obesity. We decided to do that. So we will see how this may help people on the inflammatory responses on women with obesity. Then, separate to this, we discover another compound also from annatto. It is a compound called geranyl. It's a mouthful of a word, so I'll just acronize it to GG, geranyl. And it is an endogenous nutrient, meaning that your body and my body and everybody else's body produces this compound. Enough to say this, we're launching this product this year. I'm very excited about this also. GG in the human body it does many things, but I'll focus on 3 things. It is used in our body for the synthesis of proteins and muscle. So for the working adult, it would be muscle building. For the senior, it would be to prevent sarcopenia, the loss of muscle mass and muscle tone. Very big, very important and aging thing. The second one, GG is embedded. Most people understand it. GG is embedded in the entire molecule of coenzyme Q10. CoQ10 is needed for the synthesis of energy, ATP, that. The last one is GG is embedded in the entire molecule of menaquinone 4. Most people know about menaquinone 7 to 11, always think of it as fermentation. Our body don't make it except in fermentation in our gut. True, except menaquinone 4. Menaquinone 4 is synthesized in the human body. So with that, any decent human being, scientist or not, is going to ask the question, if a human body make MK4, but not make MK7 to 11, why does it make MK4? So I'll give you the shorthand. MK4 is needed in soft tissue calcification. The hard tissue calcification is bone. 90% of the calcium is in the bone. Everybody got it. It helped the calcium to go to the bone, as vitamin D helped the calcium get in the bone. But vitamin MK4 help in soft tissue calcification. What do I mean by that? It places the calcium, 10% of calcium is in soft tissue. It places the calcium in the right place and not place the calcium in the wrong place. What is the wrong placement of calcium? The wrong placement of calcium is, if I just name to you the problem, you know right away, would be osteophyte in osteoarthritis, kidney stone, calcium in arteriosclerosis. So if you take MK4, it will not put the calcium in those places. So now GG is required for the synthesis of MK4, voila. Required in the synthesis of CoQ10, voila. And it's also required in the synthesis of protein. 70% of my body, my head, my hair, my nail, everything is protein. It's required in the synthesis. It's systemic. This GG, you got to have another interview for me. If not for anything else, what does GG do in our body? You Google and you can ask Kim or Keith to send you a white paper on GG. You should cover that. And by the way, this GG is also found in the annatto seed. The same thing I got my tocotrienols. But I know I gone way off, but I just wanted to put, if that is a good teaser, that would be a good teaser of something to come. Thank you so much. I know I overspent my time with you. I hope that this is educational for your audience, and I look forward to coming back to your show again.
Thanks so much, Barry. No, and I really enjoyed this one, and I'm relatively new to the science and mainly through your work. And I think you really decoded this whole complex situation, decades long kind of confusing science problem, and made it ultra clear relatively for all the people who are interested in promoting their own health, advancing their own health, getting all the nutrients, best foods, nutrient dense kind of calories rather than those processed food empty calories, and of course looking at taking more vitamins and minerals that we increasingly know are important, or the more important ones by the Pareto principle. You can't take every vitamin and mineral, but you can target the ones with the best evidence, the best support, and the most likely ones to extend your life and increase your health and vitality. So really enjoyable discussion, Barry, or we'll certainly be back again. And I'll just mention too in closing that we'll have a link with a code to get a free download of your PDF book all around vitamin E and specifically tocotrienols. all the studies, all the data, and all the linkages to disease and how it could mitigate those.
Well, thank you so much for this time. So if you miss anything, I have a barrietan.com, and I know you're going to list it, and then you can find out more information. Even if you just type my name, I've been doing this for 30, 40 years, and there will be many studies, many interviews out there. So come to the website periodically. We usually post new studies coming up, and there will be more. You will see there's going to be no less than about 20 or 30 studies that will show up in this 2020. They'll not just only by us, but by many scientists throughout the world. And hopefully sometime in the next 24 months, we will host the third international symposium on tocotrienol to bring together all the powers that be in this area to mine the most of this nutrient. And really, tocotrienol is an understated vitamin. It should come to the forefront, and the public should know about it. Thank you so much. Have a wonderful new year in 2020.
Thank you so much, Barry. Until next time, thank you.